Welcome back. This is Professor Shannon Gracie from Maricosta College, working out of the guided notebook we use with Blitzer's Introductory and Intermediate Algebra for College Students text. Today we're learning about the quadratic formula. We'll be doing some fun, exciting stuff. So this warm up, you can give it a try. It might be a little confusing. If you're baffled, you can just follow along with me. This is basically the derivation of the quadratic formula, right? So here we go. First of all, we want to multiply both sides by 1 over a, assuming that a is not equal to 0. And when we distribute that through, we'll end up with x squared plus b over a times x plus c over a equals 0. Good so far? I just distributed the 1 over a through those three terms. Now, we need to get the c over a to the other side. So we'll end up with negative c over a. Now this part might end up seeming a little bit confusing because the so-called b, that you learned about from completing the square is b over a. So basically what we're going to need to do in order to complete the square, the coefficient of that x to the 1 term is our b over a, and then we have to divide that by 2 and square it. So that's going to end up being, remember, b over a times 1/2 squared, which is b over 2a squared, which is b squared over 4a squared. So like we did before, we'll be using this one on the left side of the equation and then its equivalent on the right. So what that means is we will be adding b over 2a squared, and over here we'll put the end result of the squaring. Okay? So the factored form of the left side will be x plus b over 2a, the quantity squared, equals. Now on this guy, I need to get a common denominator. So to get a common denominator here, I will have times, I need a 4a over 4a to get the 4a squared. So now we'll have this is equal to negative, I'll just write it as 4ac plus b squared all over 4a squared. Now, let's do one more rewrite on the right-hand side so it looks prettier. We'll have b squared minus 4 times a times c all over 4a squared. You hanging in there so far? Okay, so now we can apply the square root property, and we will end up with x plus b over 2a is equal to plus or minus the square root. Actually, we can evaluate the top part of the fraction, the numerator, will be b squared minus 4 times a times c. The denominator is going to be 2a. And now we just need to subtract a b over 2a from both sides. So we'll get negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. They've already got the same denominator, so we end up with x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And that is the derivation of the quadratic formula. Pretty cool, huh? All right, so we're going to be using this formula for quite a ways in our math life. The beauty of the quadratic formula is if you're solving an equation that is quadratic in form, meaning that you have, ax squared plus bx plus c is equal to 0, and a is not equal to 0, that means that if you have not had very much luck solving by factoring or using the square root property, then you can use the quadratic formula. Okay, so here we go. We just wrote it. I'll rewrite it over here. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So don't forget that that fraction bar is also underneath that negative b. So here's some basic steps for using it. You need to make sure that you've got the quadratic equation in standard form, meaning that you have 0 on one side and everything else on the other. So you have your ax squared plus bx plus c is equal to 0. Also, this is only going to work if you have an equation. People start kind of making up their own math with this. If you have an expression, or a function, you don't automatically always equal it to 0. So just make sure you have an equation and you have 0 on one side, and the degree of your polynomial in one variable is 2, right? We've got a squared. Okay, determine the numerical values for a, b, and c, and then substitute the values of a, b, and c into the quadratic formula, and then evaluate the expression. And then you check your solutions in the original equation. I will leave the checks to you. Okay, so first example. So take a look. Is this in standard form? What do you think? Good. We have to get 0 on one side, so we need to subtract 2 from both sides to get this in standard form. But now it's in standard form, and we have, what's my a? Good. A is 4, b is 3, and c is, good, negative 2. You keep the sign with it. And we got these from a, b, and that was a positive. And then c, you keep the sign with it. And that's where we got that information. So you can use the, I'll write it this time. We know that x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. My advice to you is to keep rewriting that formula until you have it memorized. So x is equal to the opposite of, what's b? Good, 3 plus or minus the square root, of 3 squared minus 4 times what was my a? Good, 4. And my c was negative 2 all over 2 times 4. So again, a showed up twice. So here was my a. B shows up twice. And here it is in all its glory. And C shows up once. And here's our C. Okay? Alrighty, so we'll get x is equal to negative 3 plus or minus the square root of. So we have 9. We're going to end up getting, well, I'll do it like this. Minus, this is going to be, what is this? 16 times negative 2 is negative 32 all over 8. So we'll have x is equal to negative 3 plus or minus. Minus a minus is plus, so we'll get 9 plus 32 all over 8. So x will be negative 3 plus or minus root 41 over 8. And we're done. We've got our solution. Set is negative 3 plus or minus root 41 over 8. And again, you can write it out. I'm going to actually put this negative closer to the 3. Okay, and you can write out the 2 solutions if you prefer. I'm fine with that. Okay, so why don't you go ahead and pause the movie and give part B a try and see how you do. I'm sure you can do it. I have faith in you. Okay, let's see how you did. We've got a quadratic because we've got the squared term there, and they're all the same variable. There's x's, but it's not in standard form. So we need to subtract 4x from both sides and add 6, and we get an equivalent equation. So what's my a? Good, 3. My b is awesome, negative 4. And my c is positive 6. And again, I got that from, you got to wait till the equation's in standard form. I brought the sign with the 4, and we've got c right here. So x will be the opposite of b, which was negative 4, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So here is all our stuff. Here's a, here's b, and here is c. Now remember, you're in the complex number system for your solution, so it's okay to get an imaginary result. So if you get a negative under the radical, you'll end up with an I. So I'm not sure if that'll happen here, but just a heads up. So we'll get 4 plus or minus the square root of 16 minus 72 all over 6. So x is 4 plus or minus 16 minus 72 is, I believe, is it 56? Yeah. So negative 56 under the radical. And then we have a 6 down here. Now, 4 is a perfect square, and it's a factor of 56. So we'll get x is equal to 4 plus or minus root, I'll just write it as negative 4 times 14 all over 6. So x will be 4 plus or minus 2i times root 14 over 6. So we've got a complex number, an imaginary number, so I'll go ahead and split it. 4, 6 plus or minus 2 root 14 over 6 times I. So x will be equal to 2/3 plus or minus root 14 over 3 times I. And we're all set. How'd you do? Awesome. Okay. Now, what about part C? What the heck do we need to do here? Good. We got to multiply all this stuff out and get it into standard form. So we're going to have 2x squared plus 8x. We need to take these to the other side. So we subtract 3x from both sides and add 3. So we'll have 2x squared plus 5x's plus 3 is 0. So what's my a? Good, it'll be 2. My b is 5. My c is 3. And I got those from here once we got it in standard form. So x is equal to the opposite of 5 plus or minus the square root of 5 squared minus 4 times 2, which is a, times 3, which is c, all over 2 times 2. And so again, this is where everything, went in the quadratic formula. So we have x equals negative 5 plus or minus the square root of 25 minus 24 all over 4. So we get x is negative 5 plus or minus, well, 25 minus 24 is positive 1, so we'll just get 1 over 4. So what does this mean? That means that x is negative 5 plus 1 over 4, or x is negative 5 minus 1 over 4. So in this one, x could be negative 5 plus 1 is negative 4 over 4. So x would be negative 1. And on this one, x is negative 6 over 4. So x would reduce to be negative 3/2. And that's our solution set. So this is an example where, it could have factored, right? If you had preferred to solve it using your factoring and zero product principle. Okay, so part D. Yay! It's already in standard form. So what is my A? Good, my A is 1. My b again is 5, and my c is negative 10. Don't forget the sign with it. So this was c, this was b, oops, and this was our, and then our a was, you can actually write a 1 there. There's an implied 1. So x is equal to the opposite of 5 plus or minus the square root of 5 squared minus 4 times a times c. So that's what we had for a and c, 1 and negative 10, all over 2 times a, and a is 1. So here were the a's, here were our b's, and here was c. So evaluating, we have negative 5 plus or minus the square root of 25 minus 40 minus negative 40. Be careful with your signs. All over 2. So x is negative 5 plus or minus the square root of 25 minus a minus 40 is 65. And then 2. Now let's see, 5 divides 65, but it's only going to be what? 5 times 13. So there's no perfect squares in there. So we are done. We get negative 5 plus or minus root 65 all over 2. Okay, so next up we talk about something called the discriminant. So the quantity b squared minus 4 times a times c, which appears under the radical sign in the quadratic formula, is called the discriminant. The discriminant determines the number and type of solutions. Of quadratic equations. Okay, so here we go. Oh, my picture didn't come out very well here. Let me write in this little axis. Okay, so let me see if it happened in the lower one. It did. Okay. Okay, so here we go. If the quantity under the radical is positive but non-zero, right? What that means is you have two unequal real solutions. So, if actually, let me write it like this. If the discriminant is, so this is like our first case, a perfect square. So like, I don't know, 25 or 16 is what you get, or like we got 1 in that one of those examples before. What happens is you get rational solutions. You don't you don't have a radical left over. And this is assuming that A, B, and C are rational numbers. Second case, if it's not a perfect square, all right? The solutions are irrational conjugates. So they're real, but they're irrational, and they're conjugates. So the way it would look in a graph, you would have two x-intercepts, and your graph would, so it would cross the x-axis. So I'll just do them opening upward, but they could open downward as well. So you might have something, you know, like this parabola, and these would be your x-intercepts. Okay, now if your discriminant is exactly equal to 0, you're only going to get how many solutions? Good. You're going to get one solution, and it's actually a repeated solution. That is a real number. And the repeated solution, if you know A, B, and C are rational numbers, the repeated solution will be a rational number. So you'll end up with something like this. You'll have maybe like 1 point, you have 1 point on the x-axis, something like that. So you get 1, I was doing that in black, 1 x-intercept. Okay, and in this case, when your discriminant is negative, what happens is you get no real solutions, because you're going to have a negative under the radical. So you'll have 2 imaginary solutions, which means that there are no x-intercepts. So it either floats above or completely below the axis. So I'll just do one that's like this. So it never crosses the x-axis. Okay. So here we go. Let's compute these discriminants and figure out the number and type of solutions. So go ahead and pause the video and see how you do. So here we are. So for this guy, A is 2, B is -4, and C is +3. So when we evaluate b squared minus 4ac, we get negative 4 squared minus 4 times 2 times 3. That is 16 minus 24, which is negative 8. So we're going to get two imaginary solutions. Now this guy we have to do a little work too. So we'll have 4x squared minus 20x plus 25 equals 0. So A is 4, B is negative 20, C is 25. So B squared minus 4AC will be negative 20 squared minus 4 times 25. So that's going to be 400 minus, let's see, 4 times 25 is 100. 100 times 4 is 400. So 400 minus 400, so we'll get 0. So that means we'll have one real solution, which means one x-intercept. The problem from part A, we would have no x-intercepts. And part C, it's in standard form. What's my A? Good. A is 1. B is 2. C is negative 3. So B squared minus 4 times A times C is going to be 2 squared minus 4 times 1 times negative 3, which will be 4 minus negative 12, which is 4 plus 12, which is 16. 16 is a perfect square. So what's going to happen is we're going to have, good, two rational solutions. Okay. So here are some tips, because now you have a few different ways to solve quadratic equations. If you can easily factor once you get 0 on one side and everything else on the other, then, I mean, I would probably, if you're good with factoring, I would factor and use the zero product principle. Okay, if we have something like, if we have no middle term, right? We have an x squared term and a constant. That means that there's no x to the one term, right? Which means that b equals 0. So for this one, personally, I would isolate x squared and use the square root property. Again, next one, if you have a situation u squared equals d where u is an algebraic expression, u is a first degree polynomial, meaning it's linear, like x minus 1 or 2x plus 3, something like that, then I would use the square root property again. And then here we go. I mean, if you've got a quadratic that has all the terms and it either can't be factored or the factoring is really hard or you blank on factoring, what the heck, use the quadratic formula. Okay, so the next little bit of stuff is sometimes you want to go back and you want to find, you might have the zeros of a quadratic and you might want to find out, you know, what the equation might have been and later on maybe what the function is. So I mean, just going backwards, if A is 0 or B is 0, then A times B is 0. Okay? So here, what this means here is that your variable, we might as well just use x. This one, x was equal to -2 or x is equal to 6. So you're literally working backwards from what you're used to. So if we were to add 2 to both sides here, we would get x plus 2 is 0. And over here, if we subtracted 6 from both sides, we would get x minus 6 is 0. So now that we have each of them equal to 0, we can say, well, heck, if that's true, then if I multiply these two together, they must be 0. And then if I multiply it out to get it in standard form, I'll get x squared minus 6x plus 2x minus 12 equals 0, which gives us x squared minus 4x minus 12 equals 0. So this one works. There's, believe it or not, there's infinitely many solutions. If you multiplied this by each term by 2, it would work. You know, any multiple of this answer is going to work. But this one serves just fine. Don't worry too much about that. Okay? All right. So let's check out part B. This one tells us what? You tell me. That x was equal to, good, negative root 3, or x was equal to positive root 3. So then this is equivalent. X plus root 3 equals 0 is equivalent to x's negative root 3. X minus root 3 equal to 0 is equivalent to this other one. So now that we have them both equal to 0, we can say, hey, that means that x plus root 3 times x minus root 3 is 0. Notice that I'll get a difference of squares result. So a possibility is x squared minus 3 equals 0. Okay? All right, next up. This guy means that x was equal to 2 plus I, or x was equal to 2 minus I. So this one might be a little bit more labor intensive. It means that x minus, I'm going to put it in parentheses, the quantity 2 plus I is 0, or x minus quantity 2 minus I is 0. I know that this looks really ugly, but I think if we keep it like this, it might be easier. So just go with it. If you want to distribute the minus through each of these, go ahead and then multiply it out. So this would be x minus 2 plus I times, actually, x minus quantity 2 minus I is 0. So notice I have Well, I thought it might turn out a little easier. I think I'll go ahead and distribute that minus through each. So we'd have x minus 2 minus I times x minus 2 plus I is 0. So now I have to multiply everything through. So I'm going to start with the x. I'll get x squared minus 2x's plus x times I. I just distribute the x. I'm keeping the second parentheses as is. Now I'll distribute the negative 2. So I'll have minus 2x plus 4. And negative 2 times I is minus 2I. Now I'm on to the negative I. So I'll get minus x times I and plus 2I. And then minus I squared is 0. Okay, so the x squared stays. I'll have minus 4x's. I have a positive xi and a negative xi, so they zero out. I guess I can write that. Plus 0 xi's. And then I have plus 4. And I have a negative 2i and a positive 2i. So I'll have plus 0, i's. And then minus negative 1 because I squared is negative 1. So that's going to give me x squared. 0 times anything is 0. So I'll get x squared minus 4x. 4 plus 1 is 5. Let me double check my x term because I'm looking at this one. I think it's okay. Yeah, because I have a minus 2x, yep, is equal to 0. And we're good. So there is a result that will work. Okay, so now for an application. The hypotenuse of a right triangle is 6 feet long. One leg is 2 feet shorter than the other. Find the lengths of the legs. So we have a right triangle. And what do we know? We know that the hypotenuse is, good, 6 feet. And why don't we let the measure of this leg be x feet, and this one would be x minus 2 feet since it's 2 feet shorter. So using the whole, a squared plus b squared equals c squared idea, we'll have x squared plus x minus 2 squared, because those are the legs of the right triangle, is equal to 6 squared. So we'll get x squared plus, so this is going to be x squared minus 4x's plus 4, and then we'll get 36 over here. So we're going to have 2x squared minus 4x. I'm going to bring the 36 over here. So 4 minus 36 is negative 32. That's going to be equal to 0. Now notice that we can factor out a 2. And if you, divide out that 2 from both sides, you'll get x squared minus 2x minus 16 is 0. So in this case, you can try to figure out if it factors, or you can just say, hey, I'm going to use the quadratic formula. So here we are. do you see that my A is 1, B is negative 2, C is negative 16. So we're going to have x is equal to the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 16 all over 2 times 1. By the way, if you hadn't factored out that, 2 and simplified that a little bit or reduced it a little bit, you'll end up with the same result. You'd just be working with bigger numbers. So x is positive 2 plus or minus the square root of 4 minus negative 64 all over 2. X is 2 plus or minus the square root of 68 all over 2. Now 68 has a 4 in there, so you can write 2 plus or minus root 4 times 17 all over 2. So we'll get 2 plus or minus 2 times root 17 all over 2. But you see there's a 2 in each part, so you can actually factor out a 2 from the numerator. You get 1 plus, you know what, I don't want to squeeze that so much in there. Go to a new line. So we'll get x is equal to 2, 1 plus or minus root 17 all over 2. So the 2's divide out. So then we have to figure out, now the square root of 16 we know is 4. So do you see that 1 minus root 17 will be negative? And we don't want a negative length. So we can also say, hey, we're throwing out that negative result. So x is equal to 1 plus the square root of 17. And the other leg, right, is x minus 2. So x minus 2 is going to be x, which was 1 plus root 17 minus 2. So here x was this, right? So therefore that other leg, which is x minus 2, is going to be negative 1 plus root 17 when I do 1 minus 2. Now I did get approximation for these. So this guy is approximately 5.1 feet, and this is approximately 3.1 feet. Okay, but if I don't say to round or approximate, you need to give the exact, and then if you want to approximate after that, you can. So we should probably put our solution in words. So one leg is 1 plus root 17 feet, and the other is negative 1 plus root 17 feet, approximately 5.1 feet and 3.1 feet. And we are all done with 11.2. Have a fabulous day.